This is Initiative Smart Class. We have come to you once again with a question on mapping, specifically exponential mapping. We'll continue to encourage you to take your pen and your paper, if you have a jotter, and a book dedicated for mathematics. You can take it and write the solution. After that, get example of this question and try to see if you can solve it alone without any assistance. In fact, that will tell you that the concept has really registered in your mind. So as we lead you through the solution, try as much as possible to follow and write something down. Exponential mapping. The idea is to get a rule for the mapping. When we say a rule, we are looking at a mathematical equation that can help us predict the y values given the x values. We are looking at a mathematical equation, an expression, a rule that can help us predict the values of y given the x values. When questions like this are given, the student should be able to identify that this question is a linear mapping, exponential mapping, or is a kind of mapping where you can identify the rule by inspecting the x values and also the y values. The emphasis is on finding the rule for the mapping under exponential mapping. So we need to find out how to identify an exponential mapping. The student should be able to identify that it fits the rule for exponential mapping. So this is what the student does. For the student to identify whether it's exponential mapping, if you want to identify an exponential mapping, the ratio of the consecutive terms in the codomain is constant. The ratio of the consecutive terms in the codomain is constant. What do we mean by the ratio of the consecutive terms in the codomain is constant? You know, we have the domain here, we have the codomain here. So this is what we do. There is a general rule that we use to identify, that we use to get the exponential rule. And that general rule is given by y is equal to AR x to the power minus b. Y is equal to AR x to the power minus b. The formulas differ depending on the kind of textbook that you are using. Others use P R to the power x minus b. So it depends on where your source of information is. So this is the formula for finding the rule for the mapping. Now, if you want to check whether it's exponential, like we stated before, the ratio of the consecutive terms must be equal. This is what we mean. R which is the ratio, is equal to y sub n all over y sub n minus 1. R is equal to y sub n all over y sub n minus 1. Now, what do we mean by y sub n all over y sub n minus 1? In fact, when you write it this way, normally what we do is to name them y1, y2, y3, y4, y5, y6. So y1, y2, y3, y4, y5, y6. If you want to find a common ratio, we are saying this is the general formula for finding the common ratio. Y sub n all over y sub n minus 1. What do we mean? You know, here is 6, y 6. So if you should put 6 here, then it means that we'll be having y sub 6 all over y sub 5, because n minus 1 indicates that the n will reduce by 1, which is y sub 6 all over y sub 5. And this will help us find the common ratio. Again, if you are using y sub 5, then it means the denominator should be y sub 4. Y sub 5 all over y sub 4. And this one will also be equal to y sub 4 all over y sub 3. Y sub 3 all over y sub 2. In effect, all these should be able to produce the same answer, and that makes it a common ratio. All these are supposed to give us a common answer, and that makes it a common ratio. What of y2? If you write y2 here, then here must be y1. And all these must give you the common ratio. N minus 1. It means if you pick 5 here, it must reduce by 1, and then it will be y sub 4. If you don't get a common ratio, then it means this is not an exponential mapping. So let's check whether truly this is an exponential mapping. R is equal to, what is our, there is a problem here because the question says we should evaluate the value of k. So we can't use k here to be part of the testing. So let's leave y6, y5 out, and let's go to y5, y4. The common ratio, which is R, will be equal to y5, y sub 5 over y sub 4 will be 2 out of 4. Let's check y sub 4 over y sub 3. Y sub 4 will be 4 out of 8, which is equal to y sub 3 over y sub 2. Y sub 3 is 8 out of 16. And then y sub 2 over y sub 1 will be 16 out of 32. And this R is the common ratio. Now let's check the figures here. You could see clearly that 2 out of 4 is half. 4 out of 8 is half. 8 out of 16 is half. And 16 out of 32 is also half. So this gives us the common ratio, which is half. The common ratio is half. Now, if you identify that all these answers are giving you the same answer, which is half, then it means that it is an exponential mapping. Okay, we know R in the formula to be the common ratio, and that helps us to identify exponential mapping. They should have a ratio that is common. Now, what do we mean here by the A here? The A. The A needs to be defined. A in here is the first term in the codomain. A is the first term. A is the first term in the codomain. A is the first term in the codomain. And let's look at the first term in the codomain. Here represent the codomain. So if A is the first term in the codomain, then it means A is equal to 32. Then it means A is equal to 32. And B is the first term in the domain. B is the first term in the domain. B is the first term in the domain. So B is the first term in the domain. So what is the first term in the domain? When we come here, the first term in the domain is -1. And that means B is equal to -1. B is equal to -1. A is equal to 32, B is equal to -1, and the common ratio R is equal to half. Now we know what A is, we know what R is, and then we know what our B is. In that case, we can write the rule for the mapping. How do we write the rule? By just substituting the figures into the formula, and then we get the rule for the mapping. So follow me as we do the substitution. Y here will be equal to A. What is A? A is equal to 32. What is R? R is the common ratio. We know the R to be half. So 32 is multiplying R, which is half, all to the power X minus B. X is here. So we repeat the X. Minus is here, but a B here is coming with its own negative. The B is coming with its own negative. Negative is already there, and the B is coming with its own negative. So negative, positive. When negative meets negative, they become what? Positive. So Y will be equal to 32 into bracket here, half, all to the power X plus 1. X plus 1. X plus 1. You can leave this answer as the rule for the mapping. You can leave this answer as the rule for the mapping. And then, like we stated earlier on, you test the figures here to find out whether you'll be getting these answers. In fact, if you get any of the answers here wrong, then it means the rule for the mapping is wrong. If you get any of them, any of the answers here wrong, then it means the rule for the mapping is wrong. Now, if you want to sound more mathematical, we can break the solution down there. You can break the solution down there into its simplest form. And that is by the use of indices. You can break it down. But if a student leaves the rule in this form, he will not be wrong. But let's try to see if we can break it down. We know y here to be equal to 32 is multiplying half to the power x times half to the power 1. Check it again. Half to the power x times half to the power 1. Let's try to understand what I've written here. In indices, if you have a to the power m times a to the power n. In indices, if you have a to the power m times a to the power n, it is the same as a to the power m plus n. A to the power m times a to the power n is the same as a to the power m plus n. The student should also know that if you have a to the power 3 times a to the power 2, a to the power 3 times a to the power 2, it is also the same as a to the power 5. Okay, if you understand it from this angle, then let us also note that if you have a to the power x times a to the power 1, a to the power x times a to the power 1, then it is also the same as a to the power x plus 1. In other words, if you have b to the power x plus 1, if you have b to the power x plus 1, it can equally be written as b to the power x times b to the power 1. You can split it and make it b to the power x times b to the power 1. So that is what we have applied down there. Because we have half to the power x plus 1. We have half to the power x plus 1. And this is the same as half to the power x times half to the power 1. Half to the power x plus 1 is the same as half to the power x times half to the power 1. And that is what I've splitted it here. Half to the power x times half, because here it was half to the power x plus 1. So this can equally be written as half to the power x times half to the power 1. And any number raised to the power 1 is the same number. If that is the case, then I can write it this way. Y is equal to 32 times the half that has been freed here. 32 times the half that has been freed here, times half all to the power x. So it means these two will cancel this 32. And they will be having 16. So finally, you can write your final rule as, the final rule can be written as y is equal to 16 times half to the power x, instead of leaving it in this form. Better still, y is equal to 16 half all to the power s. This can also be written as the rule for the mapping, instead of leaving it in this form. And that is by the application of indices. Let's test and see. Let's test and then see if our rule is correct. Let's test our rule and see if the rule is correct. What is the rule? The rule is y is equal to 16 half all to the power x. Try -1 and see. Let's try -1 and see. We are putting in -1, and that will be 16 into bracket half to the power -1. 16 times half to the power -1. In indices, if you have a out of b all to the power -n, in indices, if you have a out of b all to the power -n, the rule is that let the b go up, let the a come down. In other words, the reciprocal. B out of a, and then the negative sign will change from negative to positive. So here will be positive n. This is a rule in indices, and you need to know this. Let's check our half to the power -1 and then apply the rule in indices. Okay, half all to the power -1. We need to apply this rule on the half. If you want to change the negative sign or you want to remove the negative sign, let the 2 go up and let the 1 come down, and then the negative will turn into positive. So this one will be equal to 2 up, 1 down, positive 1. Positive 1 is nothing. So in effect, we have 2 here. 2 up, 1 down. So 2 over 1 is the same as 2. So here, we are checking our rule. We are verifying whether it is correct. So y will be equal to 16 into brackets per indices 16. The bracket here will be what? 2 out of 1 to the power 1. Then 2 over 1 all to the power 1 is the same as 2. And that will be 16 times 2. And that will give us 32. That is why we have 32 here. So the first one has been verified. Let's try 0 in here. If you try 0 in here, y is equal to 16 half all to the power 0. We know that any number raised to the power 0 is 1. So half to the power 0 is 1. And that will give us 16 times 1. And that is giving us this particular 16 here. So this has been verified. This has been verified. Let's try whether we can verify that of 8. If you are verifying 8, you substitute the x value. Wherever you see x, you put the x values to check whether you get the corresponding y values. So let's try the 1 and see. By verifying 1, y is equal to 16 into bracket 1 out of 2 all to the power 1. Any number raised to the power 1 is the same number. So this one will give us 16 times half. 2 goes into itself 1. And 2 goes to it 16, 8. So we have this 8. Like we said, this formula or the rule for the mapping will help us predict all the y values given the x values. So we know that of 8. Let's try whether the 2 will give us 4. Let's substitute 2 and see whether we'll get 4. Okay, let's try 2. Y is equal to 16 half all to the power 2. Now, In indices, this should tell you that indices is a very strong topic that we need to know. In indices, if you have A out of B all squared, if you have A out of B all squared, or let me do it in a generic form. If you have A out of B all to the power n, all to the power n, the rule is that A to the power n all over B to the power n. The meaning is that you take the numerator and then you square. After that, you take the denominator and then you use this power. In this case, the power is n. So A to the power n and then B to the power what? N. So the numerator will take the power n and then the denominator will also take the power n. Now look at what we have here. We have 1 out of 2 all squared. These are in, let's say, symbolic form. A out of B all to the power n. In this case, in specific form, we have 1 out of 2 all to the power 2. So it will be 1 squared. You take the numerator and then you square it. You take the denominator and then here 2 squared. And that will give us 1 squared is 1 and 2 squared is 4. So y will be equal to 16 times 1 out of 4. 4 goes into itself 1 into 16. 4. And that is when we substituted x to be 2, we had the answer to be 4. And that is the answer we are getting here. There is the last verification, the 3. Once we know how to deal with it, if you have the x to be 3 now, y will be equal to 16 half all to the power 3. We want to choose x as 3 and check whether we'll get to the power 3. So we have 16 and then 1 to the power 3, like we stated here before. 1 to the power 3 is 1. When you multiply 1 by itself 3 times, it's still 1. And then 2 to the power 3. 2 times 2, 4. 4 to 8. So this one will give me 16 times 1 out of 8. 8 goes into itself 1 into 16, 2. So that is why we are getting this answer here, 2. In effect, the same process should be used to evaluate the value of k. Because the question is, hence, after finding the rule for the mapping, find or evaluate the value of what? K. K is y6. K is y6. So in order to find your y6, y6 also uses the same rule. So we have k is equal to 16 half to the power x. What is x in this case? X is 4. X is 4. So by substituting 4 in place of x, you use it to find the value of k. Find the value of k. Find the value of k. Like we stated here, the explanation has already been given. That in indices, a over b all to the power n, the numerator will take the power and then the denominator will also take the power. So the 1 to the power 4 is 1. And then 2 to the power 4 means you are multiplying 2 by itself 4 times. 2 times 2, 4. 4 to 8. 8 to 16. And this will be equal to 16 times 1 out of 16. And this 16 will cancel this 16. So the value of k is 1. And this is how it should be done. So the value of k is 1. And this is the rule for the mapping. God bless you wherever you are. This is Initiative Smart Class. This is Initiative Smart Class. We will continue to encourage you to like, follow, and share because more videos are coming your way. Very powerful questions are going to be selected, and we shall use those questions to address the weaknesses of students. God bless you wherever you are for following us and liking the page. Thank you so much.